Hey folks, all right, well, for lab 5, let's do something a little bit different. So we're going to get into the type checking side of things, but we'll do it using lex and yacc. So the idea is that we're going to try and take expressions in a particular language, or grammar that we'll talk about in a little bit, and we're going to try and validate what kind of values are on the left and right hand side of operands as we go through parsing these things. So what we're going to do is use the plus operator and say that the plus operator can be used for addition of integers, addition of floats, or concatenation of strings. And so, if you've got x plus y, for instance, then on either side they could be both strings, or they could be both floats, or they could be both ints. Or we'll say one can be a float and one can be an int, in which case we'll perform it as a floating point operation. So what I'm going to get you to do is we're going to have a grammar that basically takes assignment statements where you've got some variable equals and then an expression on the right-hand side. And the expression can, again, be a bunch, there can be a bunch of plus operations in there, integers, floats, and strings. And we'll treat a mix of strings with either of the other two types as invalid. So we'll get you to essentially display a message saying, we're trying to assign an invalid, or the result of an invalid operation to this particular variable. If the expression on the right-hand side is a mix of ints and floats, we'll try and say, okay, well, we're basically we're assigning this as a float, but it was a mixed data type operation. And if it was all ints or all floats or all strings, we'll just say, okay, I'm assigning an int, or I'm assigning a float, or I'm assigning a string. So this is the idea. We want to go through the process of seeing how to do this in lex and yacc. So we're going to set up, well, actually, a lot of this has been set up by default for you in the Lab 5 kind of starter files. We're going to have an integer value associated with each of the 4 data types. So one for error, one for string, one for float, and one for integer. We'll take a look at those in just a sec. And for each of the tokens and each of the non-terminals that are used in the program, we'll associate a data type value with it. So obviously when a token starts up, we'll assign, if it was an integer token, we'll assign int. If it was a float token, we'll assign float. If it was a string token, we'll assign string. So for the token types that crop up that are ints, floats, and strings, we can assign a value right then and there. For the expressions, what we'll do is say, okay, if I've got an expression where it's a value plus something else, then I'll look at what the values of those two other things are. And we're going to do it by looking up the data that's associated, the data type that's associated with those two elements. And then we'll look at them, compare the two types, and take the appropriate action. So we have to take a look at how to associate values with non-terminals and how to associate values with tokens and how to access that. And it's actually pretty straightforward once you get used to the syntax ideas. And then we'll take a look at the grammar for Lab 5 itself. So the basic syntax for accessing this stuff is, let's say I've got a rule of the form, X is made up of an A, a B, and a C, where they could be tokens or they could be non-terminals. Sorry, I used uppercase here, but they could be either. They could be, I guess the thing on the left has got to be a non-terminal, and then the things on the right can be either non-terminals or tokens. And from the point of view of this piece, it doesn't matter which they are. So if I want to assign a value to X, so let's say I've got a data type value associated, or a data type that I want to associate with X, then what we're going to do is we're going to have a struct that keeps track of information about our about all of our non-terminals and all of our token types, or all of our tokens. So in that struct, we'll have a field to keep track of the data type, and we'll have another field to keep track of the content. So if we've got a variable, then the content would be the name of the variable. If we've got a number, then the content field would be the actual number that was stored there. So the 3.7 or the 29 or whatever it happened to be. So our each of these things is going to have a struct associated with it with these two fields in it, data type and content. So when we're going through to look at a data type in there, the way we'll do it is we're going to access, so info is going to be the name of the struct that we're accessing. So info.datatype. And the way we specify which one of these things we want to talk about is by its position in the rule. So the thing on the left-hand side is given position $, if you like. So if I want to assign a value to the data type for it, this is the syntax that we're working with. $, and then in angle brackets, info.datatype, and that $, on the end is the one that tells us that we're accessing this left-hand side thing. So if I say, blat equals value, I'm putting this value into the information associated with that particular non-terminal. For the other ones, they're accessed positionally. The first one's position 1, then position 2, then position 3. So if I look at $info.datatype 1, then I'm looking up the data type that's currently associated with A. And if I do 2, it's the data type associated with B, and 3, it's the data type associated with C. If I was to look at info.content1, it would be looking at whatever content was associated with A, or if I was to do 2, it would be the content associated with B, etc. So we can go through and either look up or set the data types and content associated with any given non-terminal or token when we're going through our yacc rules. So we'll come back and talk about this again in a sec, but this is the basic idea. So for our actual grammar in this case, we're going to have, again, integers, floats, and strings as the token types for the actual data values, the literal values. We'll have variables. Oh, and we've got an error there. A variable is going to be a sequence of one or more alphabetic characters. So I have to fix that. Let me make a note. So I will correct that in just a moment. So a variable is going to be one or more characters as a token. A semicolon is just going to be a semicolon. A plus sign is just going to be a plus. A sign is just going to be the equals. Floats are one or more digits, and then a decimal point, and then one or more digits. And integers are just one or more digits. So in our lex file, we'll have descriptions of those 7 or 8 token types. Then in the yacc file, we'll have the grammar rules. So our script, our program as a whole, is just going to be a bunch of statements. Statements can be either a single statement or a single statement followed by more. An individual statement is a variable, so x for instance, an assign, so the equal sign, an expression, and then a semicolon. And then expressions can either be just a value, which winds up being a string, a float, or an integer, or a value plus, and then more of an expression. So again, you could have 13 plus 27 plus the string foo plus 5.7. So you can build up these long expressions, or it could just simply be a string or a float or an integer. Again, strings are just enclosed in double quotes and nothing fancy inside them. So hopefully the both the token types and the grammar rules make a reasonable amount of sense. So what we could see in our file is a bunch of things of the form, x equals 27 semicolon, y equals 3 plus 12 semicolon, etc., etc., etc. So this stuff is going to be pretty much stock. I'll provide that for you, and you can work with that. In the lex file, we'll go through and we'll actually have the code in there to assign an initial data type to the different literals. So if there's a literal 27, then it's going to have a data type of integer associated with it. If there's a literal 5.7, then it's going to have a data type of float assigned to it already. Similarly, the lex file is set up to store the content associated with those. So to store the actual string that's associated with a particular literal, or the actual float, or the actual integer, or the name of a variable. So we'll take a look in the lex file in a couple of minutes to see how that's all working. And what that means is that in our grammar rules, when I see a statement, what I'm going to want to do is associate C code with that. So, maybe C code after the semicolon here, or after the semi token. And say, okay, for this variable, I'm assigning a value of, and I have to figure out what the value of that expression is. So that's where I look up the value of the expression that's been assigned by one of these things somewhere previously. So in the case of strings, right, the values got assigned back in the lex file. And so we can just take whatever value is associated with a string token and assign it directly to the value. And again, you're using this kind of a syntax to assign that value across. So if I see a rule that's, value goes to string, I'm just going to say, okay, let's look up the value associated with the string token, assign it to the value token, or value non-terminal. If I see a rule for value going to float, I'll look up the data type associated with the float, and I'll assign it to the data type associated with the value non-terminal. If I see, because these things get parsed sort of bottom up in our parse tree, if you want to think of it that way, if I'm looking at the rule expression goes to value, when I look up the data type associated with value, which happened further down the tree in here, then I can just look that up and assign it as the data type for that expression. So we're kind of working bottom up in the tree here, saying, okay, well, we can figure out what the data types of each thing are based on the things it's made up out of. The complicated one comes in here, where if I've got the rule expression goes to value plus expression, then I want to look up the data type associated with value and the data type associated with expression, and then decide what I need to do with it, right? Whether it's integer integer, float float, int float, float int, or one of the combinations with strings. So in the lab specs, we've got a set of rules on what to do for each of the different combinations. So if it's a string mixed with, well, if either one of them has an error associated with an error type, then we'll just say, okay, well, there's an error in one side or the other. It doesn't matter. It's an error. If they're both the same, right, if they're both ints or both floats or both strings, then we'll just say, okay, well, it's that type, int or float or string. If it's an int and a float, or a float and an int, then we'll say, okay, we've got mixed operand types. Let's make it a float. And if it's any other combination, then it pretty much has to be a string combined with one of the others, and we'll say that's invalid. So we've got incompatible types. So what we're going to do is for each of those different rules, we'll associate just a little block of C code that says, okay, this is the type that I've just evaluated. And again, so in here, you're going to look up the data type of the kind of the things on the left-hand side, or right-hand side rather, figure out if they're compatible or not, display the appropriate message, and assign the appropriate value to the right-hand side non-terminal. That's pretty much the idea. So let's take, I'll let you go through the lab specs in more detail, but let's take a quick look at the code itself, just to make sure that this makes some kind of sense. So when you grab your lab 5 repo, you'll see there's an error types.h in there that is just hash defining values for the different data types. So int type is 0, float type is 1, that kind of thing. And that's getting included in our lex and yacc files. In that lex file, we go through and, our usual hash includes and keeping track of our rows. So for this one, and you'll see we've already got it set up here, we've got a regular expression for floats that we'll check first and see if something's a float or not. And again, it's a bunch of digits, a dot and a bunch of digits. And if it is, then we'll update which column our tracking of which column we're on. We're going to copy the content of that float, so the 3.757 or whatever it might be as text, into a character array to associate with that token. So this info content is a struct that's getting created over in the yacc file. And we've got these two variables associated with the current token when we're processing things through in Lex. We've got this YY_text that's got a copy of the characters that are in the token. And then we've got this YY_lval, which is a storage location associated with that token that yacc is going to be using. So basically yacc is saying, grab the next token and fill this in for me and tell me information about it. So we're filling that in with, at this point, the content of that particular float and returning the float type. Or we're saying that here's the content of it, it's data type float, and we'll return the token type, it's a float. Similarly, we've got a regular expression for just integers. And again, we'll copy the content of the integer, the sequence of digits, into this info.content struct. And we'll assign the data type for it as int type. And return the token type integer. So again, we're going through this process. If we've got a bunch of, if it's a variable, then the way we're going to have this set up is that variables can only appear on the right-hand side of an assignment. So all we're going to do is, we should actually be storing the content of, we should be storing the variable name here as well. I'm going to have to fix that too. So we're going to do essentially this same idea, where we'll copy the content of the variable name into the struct for that variable. It won't have a data type associated with it yet, right? Because it's just a variable on the right-hand or left-hand side of an expression, left-hand side of an expression, and our token type is variable. And then the usual ideas for handling white space. We've got a regular expression for our string literals here. Same sort of idea, it's a string type. We should be actually copying the content of the string there as well. Jeez, lots of things to check here. Okay, so we've got a variety of different values set up in the lex file. So the lex side of things shouldn't need to change for you, but you can go through and see how these data values are being established. And then in the yacc side, what we've got going on is here's where that data type is getting set up. So our info struct is of type struct node info, and again it's got a character array for the content and it's got a long to hold the data type. So this is going to hold that -1, 0, 1, or 2 depending on the data type we decide, and this is going to be the part that holds either the variable name or the contents of the string or the sequence of digits, or the 3.47 or whatever it happens to be. And then we go through and list each of the different token types that we're supporting, and they're all going to have this same underlying data structure. It's one of these node infos, and all of the different non-terminals we're using, and again they're all going to have this same kind of information associated with them. And then our grammar rules, right? Our script can be a bunch of statements. A bunch of statements can be either just one or one followed by more. A statement is a variable name, the assignment operator, an expression, and a semicolon, right? So this is pretty much the grammar idea that we've walked through. And so here we want to go through and look up the data type associated with that expression, which will get figured out in the rest of the parsing process, and look at that and say, okay, well, if it's an error, then we're assigning an invalid data type to variable. If it's an int, we're assigning it, etc., etc. And then for the others, again, we're just going through looking up the data type associated with value, for instance, and saying, okay, well, that's the data type that we're assigned to our expression, or the data type associated with integer, that's what we'll assign to value, or the data type associated with string, that's what we'll assign to values data type, or the data type associated with float, that's what we'll assign to values data type. And the only complicated one is that one, where we're going through and saying, okay, well, let's look up the data type for that one, look up the data type for that one, and figure out, based on those, what we should be printing out and what we should be assigning as the data type for the expression. So, lots of fun. There are the ideas. I will go through and fix those couple of glitches in the lex file and the lab webpage, and we should be in good shape. Take it from there.